In this devlog, I will be talking about my procedural world generation, or my portal worlds. This is where you expel the evil attacking your village and gather loot. The first time I had shown off this part of the game was at the end of devlog 0. The mesh was flat, and the goal was using terrain to deal with heights and painting of the terrain. My thought process has changed since then, and I've decided to perform changes of the height while the mesh is being procedurally generated. As you can see, I have added different heights at the main areas where you will be battling to give the place depth. But if two areas have large changes in heights, there would be no way to get from area to area, so I need to create a ramp connecting them. In order to do that, with my micro brain, I need to visualize it myself, so I created a simple scene with spheres that measure the angle between them. This also helps me make sense of the angle functions that Unity provides and get a better understanding of the math. What this achieves is checking the steepness of the two spheres in a cone shape. After putting the math into the mesh creation, I know that it will work. So now I need to take the steepness and apply it to the actual line creation, which took quite a while. As you can see, sine of the delta y was working on certain slopes, but not all. I finally figured out the equation, and it was simply the height divided by the longest side, as the longest side is the amount of iterations needed to finish the line. It wasn't my brightest moment, but here's the results. Next up on the list was to raise the surrounding mesh to be the same height, but this attempt just brought the point outside the edge tiles to be the same height as the room tile. Not what I want. So I altered the code to not just change the edge tiles of the room, but the edge tiles of both the rooms and the connections between them. Voicing over this and seeing my previous attempts at solving the code feels so weird. I'm sitting here, reading the code I've written, and just knowing that this isn't the solution to my problem. I can't say if it's a hindsight thing, or just understanding the code from a fresh mind. As expected, this code still didn't work. I have finally found a solution to raise the height of the surrounding floor based on the walkable path on the mesh. Here's a rundown on how I did this. I created a massive room that encompasses all walkable areas of the map, then made a list of all of the edges. I have a 2D array the size of the map that will hold the data of whether or not the current coordinate has already been altered. Now I will use a queue to set up some starting areas to begin altering the heights. I didn't know this at the time, but this way created the nice looking cliffs/hills where two opposing heights meet that you will see in a second. Now I just go through each tile, check and update the non-diagonal tiles based on the tile in the queue, and once that is completed, I queue up the tile that was just changed to continue changing neighboring tiles. This worked very well. It isn't perfect, but I'm definitely happy with this solution. The mesh still looks very plain and flat, so I decided to add purlin noise to create some more depth. This is really easy in Unity as they have a built-in function that returns a float between 0 and 1. I just multiplied this float with an intensity and added it to the heights of the mesh, and the results are as expected. With that all done, I wanted to add more detail to the mesh to have less harsh cliffs and slopes, basically make it look smoother. So my first thought was plugging in the heights of the mesh to a terrain, and then from there be able to basically subdivide the mesh for more detail. I had tried making the terrain size larger and make it smaller later to have more vertices, but this did not work. After a lot of research, I realized this wasn't really a thing, and that doing this with terrain wasn't the correct path yet. I then decided to go back to manipulating the mesh again and adding more vertices there. The way I achieved this was by creating a map of the same size but with more vertices fitting in the space. I created a 2D array with the size of the original map multiplied by the amount of detail I would like. I then looped through all the original map indexes and set the new map's indexes corresponding to the original index. So if the amount of detail desired was 2 times, I would set the new map's starting index, which is the same as the original index, and the index plus 1 in the x, index plus 1 in the z, and the index plus 1 in both x and z, so on and so forth. The height change is a little bit more complicated, and I don't believe what I have is correct, as it doesn't seem to work properly. But the way I achieved this was similarly done to the map enlarger, with the addition of an equation that gets the smoothed height depending on the index. Let's say I want to double the vertices, and I have a height of 0 at index 00 of the original map, and a height of 1 at indexes 01, 10, and 11. That would mean the new map's height would have a lot more indexes that would need to be filled in. And to do that, I take the farthest index in the square in both the x and z direction accordingly, subtracted by the original location and divided by the level of detail, in this case 2. This will get me exactly the increment needed to not make sharp angles. Basically the same idea used to create the ramps between the areas. The only thing left to do is populate the new array at the correct indexes with the correct increment. Side note, as I'm editing this, I realize now that this doesn't really make much sense, as I would never get to 2, 2 in the larger map from 0, 0 in the original. I will keep note of that when I attempt to fix this issue. Now back to the video, and here's how that looks. It works very well with 1 times level of detail. 2 times level of detail seems to have its issues. 3 and 4 times detail just seems to be completely messed up. I'm not sure as of yet why this is happening, but I will figure this out. It does appear to be adding more vertices, as you can see, it's just not working properly. That's about all I've got for this week, so thank you for making it this far in the video, and I will see you all next time. See ya!